Hello students, welcome to lecture 7 of our online chemistry classes. Last class we started with the coordination number, and we said coordination number is the number of what? Number of particles immediately adjacent to the given particle. Then we have seen what is coordination number in various cubic crystal systems. The first one is simple or primitive cubic unit cell. It has coordination number equals to 6, BCC has 8 and FCC has 12. Then we talk about the close packing in one dimension, where the spheres are nothing but particles, constant particles, are arranged in one plane. Coordination number equals to 2. Then close packing in two dimension. We can have two types of arrangement, A, like that, which is called as square close packing, or we have A, B, this type of arrangement. We call it as hexagonal close packing. The packing efficiency, the optimum packing occurs in hexagonal than the square. And the empty space created, void created, is triangular. Then we talk about the close packing in 3 dimension. We arrange one layer A, and we are arranging second layer now. We have 4 options here. First is the second layer is to be arranged to be exactly above the first layer, A, like that. We call it as square close packing. The coordination number is of course 6, and only polonium element is having this type of packing. Then another one is we arrange first layer A and second layer in the depression of the spheres, which voids which are created by the first layer. And when we arrange like that, we have 2 options now. 2 types. Why we have 2 options? Because 2 types of voids are created. One type of void is around the 4 spheres. We call it as tetrahedral void. And one type of void is around that void has 6 spheres around it. We call it as octahedral void. If we fill the tetrahedral void, the third layer A is like first layer A. So it is A, B, and we call this as hexagonal close packing. The coordination number is 12. Or we have another way where octahedral void is filled. If we do that, the third layer is different than first layer. So arrangement is A, B, C. We call this as cubic close packing, or we call it as face centered cubic packing. We have drawn various diagrams to illustrate this. I hope that you also have drawn diagram and understood how this packing is present in crystal system. Now we have one more type of concept here. We call it as void. So we have 2 types of voids. One is called as tetrahedral void. Yesterday I have drawn this diagram, tetrahedral void. And another is octahedral void. That diagram also we have yesterday drawn. The first difference is coordination number. Tetra means 4 and octa means 6. So this type of 6 spheres, octa means 8. But this type of octahedral void is created when there are 6 spheres around that particular void. Why name octa is there, we will see. Now, next point is the location of this tetrahedron. Location of tetrahedral. For that, I will draw one diagram here. Carefully you understand location because there are many questions on the void. So this is cube. I have drawn simple cube, and in FCC the particles are present all the corners as well as on the face center like this. And here is again face center. Here is face center. Here is face center and face center, and here is the corner. Right. So this is corner, this is face center, this is face center. Face center of top, face center of left. This face center of front, and this face center of rear, like that. This is corner, face center of bottom, and face center of, we can say, right. This left, this is right, like this. Now these are the particles. Face center, corner, and we can say front face center. If we connect these points like this one, this type of void is created. This void is called as tetrahedral. The same thing is here also. The same thing is for this rear particle also, like this. So around this void, around this four particle, this void is created. That's why this is called as tetrahedron. So where these voids are present, we call from this part to this part as a body diagonal. So we can say 2 on each body diagonal. And that's why we can say number of tetrahedral voids per unit cell. There are 2 and there are 4 body diagonals, and their number is 8, because for this body diagonal 2, for this body diagonal 2, for this body diagonal 2, and for this body diagonal 2. There are 4 body diagonals because there are 4 upside parts from this to this, this to this, this to this, and this to this, like this. And every body diagonal we have 2 such voids. So number of tetrahedral voids per unit cell is equal to 8. Now what is the location of octahedral void? Octahedral voids are present on 2 different locations. See these locations and their exact number, because once you understand, you will not to remember all these things. Diagrams can be easily remembered because that can be a picture memory, but of course you should draw it, then only you will remember. If you just see in textbook or on the board, you will not remember it. So this octahedral void location we are drawing here. So octahedral void is created first in body center. How it is created in body center? You can look at this diagram. This is one face center, this is one face center. We'll connect it. Then this is one phase center and this is one phase center. We'll connect it. This is top, bottom, left, right, and this is front and rear, like this. And here is that white. We call it as an octahedral white. White is called as octahedral white because if we connect all these particles here like this, and then this one like this, and then like, yes. So this type of white is created and this type of 8 angles are created just like octahedral geometry. That's why this is called as the octahedral white, where it is present in body center. It is present in body center. This also we should connect. This point. When you draw yourself, you will understand how it is to be created. Body center. So this type of octahedral white, which is present in unit cell, which is at body center, is 1 because there is only one body center. But there is one more location of this octahedral white. And that is on the edge center. This one. 1, 2, 3, 4. Of the this 1, 2, 3 form same. There is a one cube here, and there is this type of one particle around it. If we connect all these things, we can draw like this. Once again, octahedral will be created around it. Here is that point, which is at the edge center. So how many edge centers are there? There are 12 edge centers. So 12 octahedral whites are present, but number of octahedral white per unit cell is that we know that the particle present at edge center is shared by 4 unit cells. 1, 2, 3 and 4. So it is 3. And if we add all this together, 1 is at body center, 12 at edge center, but their contribution is 1/4. Then we can say number of octahedral whites per unit cell is equal to 1 plus 3 equals to 4. And number of tetrahedral whites per unit cell is equal to 8. Already we have explained that. So conclusion is number of atoms or particles per unit cell in FCC is equal to 4. We'll consider this as N, capital N. Number of octahedral whites is also equal to 4. So that also equals to capital N. They are same in number. but number of tetrahedroids is equal to 8, and that equals to 2 times of capital. So if number of particles in unit cell is n, capital N, number of octahedroids is also n, and number of tetrahedroids are equals to 2 times of that capital. Very important formula, because we can calculate the formula of a substance if we know how many octahedroids are filled, how many tetrahedroids are filled, and how many particles are closely packed. So you just remember their locations and number. Tetrahedroid on body diagonal, every body diagonal 2, 8 in number. Octahedroid in body center, contribution is 1. On edge center, contribution is 12 into 1 by 4, 3. Total is 4. Particles 4. Octahedroids also 4. Tetrahedroids 8. Particles capital N. Octahedroids also capital N. And tetrahedroids 2 into capital N. So based on this information, we have to solve some questions. To draw this diagram, they are not at all difficult. They are not at all difficult. If you have difficulty in drawing diagram, you can meet me personally, because once I draw in your notebook, you will feel easier how to draw it. But believe me that they are not at all difficult. If you try yourself, definitely you can draw better than this. Of course, some practice is needed. It is not that in the first attempt itself you will get this diagram correctly. But you can read the description from textbook and notes and see whether you are getting this diagram correct or not. That you can do at any time. Right. Now some very important questions. In MCQs also where we come across this type of questions. So these questions now we start. These are on the whites. So very carefully these questions needs to be solved. We'll have practice of this. The first question is magnetite. A magnetic oxide. This is a magnetic oxide of iron used on recording tapes. Of course, now recording tapes are antique objects in our history. We have very sophisticated device, but they are on recording tapes. Crystallizes with iron atoms occupying 1/8 of tetrahedrals. Tetrahedral. Holes means whites. And half of octahedrals. In a closed packed array means arrangement, regular pattern of oxide ion. What is formula of magnetite? What is formula of magnetite? So this is question before us. So what we have iron atoms Fe, and we have oxygen, oxide ion, this oxygen, right? This is present in that particular compound. Now oxygen is closely packed. For that we have to consider this as N. And where is iron present? Iron is present 1/8 of tetrahedral voids and half of octahedral voids. So 1/8 of tetrahedral voids and half of octahedral voids. This is the composition of iron. 1/8, if N is particles, tetrahedral voids is 2N. If N is number of particles, octahedral void is N, and this is what to take it as N. We have to take ratio of that, and then we arrive at formula. So this is nothing but N/4 plus N/2, and oxide is N. We can take LCM 4N, and this is 2N, and this is N. We can write Fe as 3N/4, and oxygen as just N. We can cancel this N. It is common to both these atoms. And we have to multiply it by 4, so that 4 get cancelled. So what we have 3, and we have multiplied by 4. It also should be multiplied by 4. So it is 4. So formula is Fe. This is the formula. Try to understand question. Oxide ion was closely packed. Number of particles are capital N. Iron was occupying 1/8 of tetrahedral void and half of octahedral void. Tetrahedral voids are 2N. Octahedral voids are N. 2N/8 is N/4. N into 1/2 is N/2. N plus 2N by 4. 3N/4. Multiply by 4, 3, 4. Fe3O4 is the formula. Not at all difficult. You have to read the question carefully and solve it in proper way. Of course, we will solve many such questions so that you will have enough practice of it, and we will cover all the variations which will be there in this question, so that a very sound background of MCQs we can have. So question number 2 is, in a cubic lattice, the close packed structure of mixed oxide, the close packed structure of mixed oxide of lattice is made up of oxide ions. One-eighth of tetrahedral voids, 1/8 of tetrahedral voids are occupied by divalent ions A plus 2 and 1/2 of octahedral voids are occupied by trivalent ion. Trivalent ion B plus 3. What is formula of oxide? What is formula of oxide? Yes. See situation here. Here we have oxide ions and we have cations A plus and B plus 3. So we can write like this. There is oxide ion, there is B plus 3 ion, and there is A plus 2 ion. Where are the oxide ions present? The lattice is made up of oxide ion, so it is N. Generally, cations are smaller, and that's why they are pushed into the voids, empty space. Anions are larger, that's why they take the position of corners and the face centers. So 1/8 of tetrahedral voids occupied by divalent ion. 1/8 of tetrahedral voids of A and half of octahedral void of B. 1/8 into 2 times of capital N, half of capital N, and this is N. So this is N by 4, this is N by 2, and N multiplied by 4. 4 get cancelled. 4 by 2 is 2. So it is capital N, 2N, 4N. Divide this by N. 1, 2, 4. So the formula is A, B, 2, O. This is the way in which this question can be solved. Right. Now we'll go for third question. We have to maintain speed. If you are thinking that this is very fast, you can reduce the speed, or you can pause and complete your work and then you can resume the question. Right. So see the third one. In a crystal solid anion C, in a crystal solid anion C are arranged in cubic closed packet, which is nothing but FCC. Arranged in cubic closed packing. Cation A occupy 50% of tetrahedral voids. And cations B occupy 50% of octahedroids. What is formula of solid? How we can calculate formula of solid? Formula of solid is nothing but formula of unit cell, and formula of unit cell is nothing but ratio of atoms and voids, and that is given in this particular question. So we have A, B and C. So I have to calculate their exact ratio. A, B and C. C are present in cubic closed packing, so it is N. 50% means half of tetrahedroids, and 50% again means half of octahedroids. It means it is half of tetrahedroids is 2n, half of octahedroids is n, and this is n, because number of octahedroids is same as number of particles. Number of tetrahedroids are 2 times of number of particles. It is just capital N. This is n by 2. This is n multiplied by 2. So that this to cancel. We have 2n, n, 2n, 2, 1, 2 is the ratio. So we can write formula as A 2, B, C 2. In this way we can complete this formula. Right, so this is third question. Then I will give you or will solve. Then I will do last homework. Question number 4 will do now. In question number 4, this is from textbook exercise. Question number 19. We are solving. Ferric oxide crystallizes. Ferric oxide crystallizes in HCP, which is same coordination number as that of FCC and CCP. Array of oxide ions with 2 out of every third oxide ions with 2 out of every third octahedral holes occupied by ferric ions. Occupied by ferric ions. Derive formula of ferric oxide. Derive formula of ferric oxide. Very simple question. I think you can solve yourself. There is nothing difficult into it. There is a ferric ion, Fe plus 3 is ferric, Fe plus 2 is ferrous. Fe plus 3, and there is oxide ion. It crystallizes in Cp, and every 2 out of every third of octahedron means 2/3 of capital N, which is nothing but 2n by 3, and this n multiplied by 3, and it becomes 2n, 3n. We can cancel n here, 2, 3. This formula is Fe2O3. Right. So these similar questions we need to solve, but before that I will give you 2 questions as a homework, and then we will solve these remaining 2 questions together. The question which I am giving you homework, it's question number 1. In a solid, oxide in a solid, oxide ions are arranged in CCP, cubic close packing. Cations A plus 3 occupy 1/6 of tetrahydroids, and cations B plus 3 1/3 of octahydroids. What is formula of compound? And I will not solve this now in the class, so this is the answer for it. You can verify your answer. Simple question, we have solved this type of questions. One more guide as a homework. Compound is formed by 2 elements X and Y. Y, will not write that. Atoms of Y makes CCP, and X occupy all octahydroids. Yes, simple question. Number of atoms, number of octahydroids are equal. What is formula of compound? Your answer should be XY, isn't it? But you can write 2 steps and get that answer. Now 2 last questions are there which we will do together because they are slightly different questions. There is possibility of this type of questions can be asked in MCQs. In chromium chloride, chromium balance is 3, chloride CrCl3. The chloride ions have CCP arrangement. CCP arrangement. Cr plus 3 are present in octahydroids. octahedroids. What fraction of octahedroids? What fraction of octahedroids and totaloids are occupied is the question. We can say number of chloride ions present in packing is equal to 3 because this is the formula. That equals to n, isn't it? Number of particles are n. Hence we can say number of octahedroids is also equals to n. Number of tetrahedroids is equal to 2n equals to 6. So we can say total voids 3 plus 6 9, isn't it? Because particles are 3, octahedroids are also 3, tetrahedroids are 6. Total voids means number of octahedroids plus number of tetrahedroids. 3 plus 6 is equal to 9. And they asked about the fraction of octahedroids. So you can say fraction of octahedroid occupied is equal to, how many octahedroids are there? 3. But how many chromium are there? Only 1. So it is 1 by 3 is the fraction. Voids occupied, total number of voids. Fraction of total voids occupied, because they asked that also. Total voids are 9. How many chromiums are there? 1. So it is 1 by 9. In that way we can complete this question. And there is one last. I'll write here. Crystalline solid is made up of X, Y and Z atoms. Atoms of X form FCC packing. Atoms of Y occupy tetrahedroids. While atoms Z occupy atoms Y occupy octahedroids. While atoms Z occupy tetrahedroids. What will be the simplest formula What will be the simplest formula of solid? If atoms along one body diagonal are removed. So this is the question before us. So we can say that number of atoms of X, Y and Z first we will calculate. Atoms and their number. Atoms is X, Y and Z. X is occupying in FCC. That's why we can say that number of atoms in FCC is 8 into 1 by 8, 6 into 1 by 2. We know it is 4. How much is the Y? Y occupy octahedroids. That is also equals to same number. And Z occupies tetrahedroids. So it is 2L. But they have removed body diagonal. Here is X and Y is on. Where is Y? Y is by octahedroid body center, and X occupy tetrahedroids. 2 are there on every body diagonal. If they are to be removed out, how much of X remains? It will be, initially it was 4, but we have to subtract 2 from that. But these 2 atoms, but their contribution is 1 by 8. So 2 into 1 by 8 we are subtracting, because body diagonal has been removed. It is 1 by 4. It is 4, and then this is 1, so it is 15 by 4, isn't it? Then what about the Y atoms? They are 4 in number, but there is only 1 here. Its contribution is 100%. Its contribution also 100%, because they are inside the cell. So it is 4 minus 1, 3. And Z is 8 minus 2, which is 6. So what we are getting here is X, Y and Z as X is 15 by 4, X is 15 by 4, Y is 3, this is 6, multiply by 4, 15, 12, 24. Again divide by 3, 5, 4, 8. So we have X 5, Y 4 and Z8 will be the formula. X 5, Y 4 and Z8 will be the formula. So look at the last question, not at all difficult. All questions are very easy. Complete these 2 homework sincerely. Solve it 2-3 times. Draw all the diagrams and you will understand. So thank you for watching this video.